Hello everyone, my name is Jasnoor Kaur and today I will demonstrate my task 4.2C for embedded system development, which is based on our Arduino multiple interrupts. The main aim of this task was to understand how interrupts work in Arduino and how we can use them to handle multiple inputs simultaneously. In this experiment, I used two inputs, a push button and an ultrasonic sensor to control two LEDs at the same time. The green LED is controlled by the push button using an interrupt, while the red LED is controlled by an ultrasonic sensor based on the distance of the object. The key goal was to make both input work together, but giving priority to ultrasonic sensor whenever the object is detected nearby. Now let's move to the hardware setup. I used an Arduino Nano, a push button, two LEDs, ultrasonic sensor, resistor, jumper wire and a breadboard. The push button is connected to pin number 3 and 5 volt. The green LED is connected to pin number 9 and the other leg is connected to the ground. The red LED is connected to the pin number 8. The ultrasonic sensor VCC is connected to 5 volt and the ground is connected to the Arduino's ground, and the trigger pin is connected to pin number 4 and the echo pin is connected to pin number 5. This setup allows the Arduino to constantly read distance values from the ultrasonic sensor while still responding instantly to both presses using interrupts. Now let's go through Arduino code briefly. At the start of this code, I define all the pin number for the button, LED and the ultrasonic sensor. I also created a volatile boolean variable called button pressed as act as a flag. This variable becomes true whenever the button is pressed. The another variable green state keeps track of whether the green LED should be on or off. Then I define the interrupt service routine called handle button interrupt. Inside the function I just set push button pressed equals to true. It's important to keep this function very short so that the interrupts does not cause any delay in the system. In the setup function, I used an attach interrupt to link the interrupt pin 3 so that every time the button is pressed, the interrupt is triggered instantly. I also initialize the pin modes for LEDs and the ultrasonic sensor and start the serial monitor at the baud rate of 3600. In the loop function, there are two main tasks happening. Control firstly, the program check if the button pressed is true. If yes, it toggles the green state. Then it resets the flag back to false. This ensures that each press of the button changes the LED state. Now, in the ultrasonic reading, every 100 milliseconds, the Arduino sends a trigger pulse for the trigger pin. It then measures the time taken for the echo to return using the echo pin. Using this duration, the code calculates the distance in centimeters. Next, there is a priority logic inside the loop. If the distance is less than 20 centimeters, the red LED turn on and the green LED turn off, giving the ultrasonic sensor higher priority. If the distance is greater than 20 centimeters, the red LED turn off and the green LED returned to the state controlled by the button. Finally, I used several serial print statements to display messages on the serial monitor, like green LED on, object detected, red LED on, no object, red LED off. These messages help me confirm that the system is working exactly as expected. After completing the circuit and uploading the code to the Arduino, I open the serial monitor at 9600 baud rate. It will take some time. Now, at first, both LEDs were off. When I pressed the push button, firstly the both LEDs off. Next, I tested the ultrasonic sensor. When I moved my hand closer to the sensor within 20 centimeters, the red LED on and the green LED turned off automatically. The serial monitor display ultrasonic detected object, red LED on, green LED off. Whenever I move my hand away, the red LED turn off and the green LED come back to its previous state, showing no object, red LED off. When I press the push button once, the green LED turn on and the serial monitor shows the message green LED set to on. When I pressed it again, the LED turn off with the message green LED set to off. This proved that the interrupt was working perfectly and reacting instantly to every button presses. Finally, overall, the system worked very smoothly. The interrupt mechanism ensured that the button input